Hello everyone. In this video, I will go over the solutions to problems of the week number 3. Question 1 is actually a pre-calculus problem that has to do with exponential growth. So this is just a review of pre-calculus. Remember from your pre-calculus class, the formula for population growth is P equals to P0 e to the RT, which means the population on the future depends on the initial population given a specific rate of growth, which this is actually not given directly in the problem, so you have to figure that out first. Here, what you know is in 10 years, the population is supposed to be 55,000 when the initial population is 50,000. So what that means is the 55,000 should equals to 50,000, which is the original population, e to the r is not given, that's what we need to figure out first, and t is 10, the time. Then if you divide both sides first by 50,000, this cancel, and from here you end at 1.1 is equals to e to the r 10 or 10r. So actually 10r could look better, so 10r. So using, again, pre-calculus, if you take log in both sides, that means ln of 1.1 should equals to 10r. Why is that true? Remember from pre-calculus, the ln e is just equals to 1. Hence, from here, r will be equals to ln of 1.1 divided by 10, which is 0.00953. But the question is asking you what will be the population in 20 years. So therefore, you substitute the value for r, which you already know. So therefore, p is going to be p0, which is 50,000, times e to the 0.00953 times 20. And once you compute this is around 60,500 if you round it to a whole number. Now, before moving to number 2, just recall a few things from trigonometry. Recall the derivative with respect to x of cotangent is equals to minus cosecant square. So this is minus cosecant square. And also recall the 1 over sine square is the same thing as cosecant square. Okay, so that's going to be very useful. Hence, if you rewrite the integral before you solve it, you don't have to, but it could make it easier. This is the same thing as e to the cotangent x times cosecant square x dx. So therefore, if u is equals to cotangent x, using the substitution method from calculus 1, this will be minus cosecant square x dx. So therefore, this should be e to the u du. And to balance this, you need a minus sign in front. So therefore, the integral for this is minus e to the u plus c, where u is just a cotangent square plus c. And that's it. Okay, so now let's move to 2b. So recall from pre-calculus 2, the e to the 5 plus radical x is the same thing as e to the 5, which is a constant, times e to the radical x. And also recall the derivative with respect to x of the square root of x is 1/2 x to the minus 1/2. which is the same thing as 1 over 2 radical x. So before we actually solve the problem, it's a good idea, not necessary, but a good idea to rewrite this. So therefore, this is the same thing as e to the 5, which is a constant, goes outside, e to the radical x divided by radical x dx. This problem also requires that we use substitution from calculus 1. So u will be radical x, the u, we already checked that, was 1 over 2 radical x dx. So therefore, you balance the equation, so you need the 1/2 is not there, so you need to multiply that by 2, so there will be times 2 the integral again of e to the u du, because the du includes this part, so the du is in there. So therefore, this will be 2 e to the 5x, which is a constant, e to the u plus another constant. So this should be 2 e to the 5 e to the radical x plus c. Now, you don't have to check, but you can always check that your answer is correct by just taking the derivative for this. So you take the derivative of this, should give you this. Let's move on to 2 part C. Here we're going to need a substitution. U equals to ln x. The u therefore is the x over x. So we will write this. This is just the integral of sinh, which is hyperbolic sine of u du, but the integral of hyperbolic sine is just hyperbolic cosine plus c. So therefore this is just cos ln x plus c. And finally, for number 3, by definition, sinh x is equals to e to the x minus e to the minus x divided by 2, and cos x is equals to e to the x plus e to the minus x over 2. So essentially, the only difference between the two is the minus and the plus. But also recall that the hyperbolic tangent is the same thing as just hyperbolic sine as hyperbolic cosine, which is essentially the same thing as tangent is just sine over cosine from pre-calculus. So therefore here, that means the tangent, or hyperbolic tangent, sorry, is equals to sinh over cos from here. But sinh is equals to e to the x minus e to the minus x divided by 2. Remember that when you divide two fractions, you multiply by the reciprocal, so this becomes 2 over e to the x plus e to the minus x. The 2's clearly cancel, so this is e to the x minus 1 over e to the x divided by e to the x plus 1 over e to the x, which you simplify the top and you find the LCD, you end up with e to the 2x minus 1 divided by e to the x, and then on the bottom is this, so it's another fraction, so you have to multiply by the reciprocal again, and it should give you something similar. This should be e to the x divided by e to the 2x plus 1. This cancel again, so you end up with e to the 2x minus 1 over e to the 2x plus 1, which is exactly what you wanted to show. There are many ways to simplify the algebra, so this is one of the easiest ones, but this is definitely not the only way to simplify. You could just find the LCD from the start here, but it's up to you. As long as you use a legal way to do this, it's fine.